R equals A sine B theta. Well, it's one term, so it must be a rose. B is the number of petals when B is odd. And A is petal length. So let's talk about 5. I'm just keeping petal length 5 so we don't have to think about it. Sine 1 theta. Oh, we've already done this. A rose of 1 petal is a circle, and we saw what that looked like. There it was. And this gave us the point R theta was 5 comma pi over 2. And so we see, because it's sine, automatically it has at least theta equals pi over 2 symmetry. You can see we don't have polar axis symmetry here. But whatever happens to the left happens to the right with this one. Let's now consider a rose with 3 petals. Remember, this is the number of petals. So this is 3 petals. And we know 360 divided by 3. They're almost like magnets repelling each other. They want to be as far away from each other as they possibly can be. Now here comes the tricky part. If I choose theta and pick R and I do pi over 2, then I get 5 sine 3 times pi over 2. Well, sine 3 pi over 2 is -1 times 5 is -5. So what does that mean for us? Here is the point R theta, -5 comma pi over 2. Remember, this would be the point up here, 5 comma pi over 2. Directed distance, directed angle. The negative in front of the R says reflected over the pole. So here is one of our petals. And we know we want 120 degrees between each of the petals. So this almost looks like a bunny rabbit. What am I saying? This here is 120 degrees. And so is this in either direction. So this almost looks like a little bunny rabbit to me. Can you see with the big ears? Or a moose or something. But don't forget that if we're talking about, this is R equals 5 sine 1 theta. So it was 1 was up. And if we're talking about 3, then I say to myself, oh yeah, 3 was down. Oh, Mr. Curran, that's hard to remember. Oh, then don't remember it. You can always do an R theta and figure it out. And say, oh, okay, that was the one that was down. 3 was down, 1 was up. What about 5? We move on to a rose of 5 petals with the sine. What if we put a negative there? Well, again, I'm going to use my theta R trick, and I'm going to choose pi over 2. Well, this becomes -5 sine of 3 times pi over 2. I know sine 3 pi over 2 is -1 times -5 is 5. So we have to know how to graph this. 5 pi over 2, oh, that's up here. So here it is. And again, 120 degrees between the petals means it's like this. So a negative reflected this over the polar axis. Notice it says sine, so we get at least theta equals pi over 2 symmetry always. Cut in half this way. So the negative flipped us. Don't tell me this is a cardioid. This is not 5 plus 5 sine theta. This is 5 sine 5 theta. One term means it's a rose. Number of petals is 5. Sorry, number of petals is 5. So here we have number of petals is 5. Because it's odd, it's just that number of petals. And here is petal length. I want to know where its head is. So I'm going to choose theta and calculate R. Well, if I put in pi over 2 here, I get 5 sine of 5 times pi over 2. Notice, we have to multiply 5 times pi over 2 and then take the sine of it. So sine of 5 pi over 2 is 1 times 5 is 5. Look, I know my unit circle very well. So what does that mean? At an angle of pi over 2, we have this. Here's our point, 5 comma r theta. And so if I'm dealing with 360 degrees to play with divided by 5, I know there's 72 degrees between each of the petals. So Here, if I go down to the polar axis, that's 90 degrees. So 72 might be here, and then here and here. Notice 5 is up. The head, the one that gets bisected, is up. Also notice that theta equals pi over 2 is the only symmetry we get. That should be no surprise because it's associated with sine. We always get at least that theta equals pi over 2 symmetry. So all other factors being equal, if I put a negative here, then I can play my little theta r game and choose pi over 2 again. I have negative 5 sine of 5 times pi over 2. Notice I'm going to multiply my angle by 5. Sine of 5 pi over 2 is, again, 1 times negative 5 is negative 5. So here is the point r theta, 5 comma pi over 2. If I want the opposite of that, that's going to be down here. So I know I've got this 72 degrees between petals. I get this. And here, what I'm talking about is to the spine of this. This is 72 degrees. So if I do the opposite of that, the positive 5 sine 5 theta was head up, a negative moves my head down. Is it a lot of work for me to figure this out? No, not at all. And again, we have this theta equals pi over 2 symmetry. That's all we get here. If I astrograph 5 sine 7 theta, one term, it's got to be a rose. We have an odd number of petals, so we have 7 petals, 7p for 7 petals, and I'll say PL, petal length, is 5. Notice I've kept that at 5 just to make things simple, so we can always concentrate on the number of petals. I know 360 divided by 7 is about 51 degrees. So now I'm concerned, where is the head for this positive 5 sine 7 theta? I know that 1 was up, 3 was down, 5 was up. I bet this one is down if I continue the pattern. Let's see. If I choose pi over 2 and I calculate r, my angle, rather, this should be theta, not pi over 2. In general, I'm picking theta, pi over 2. I get 5 sine 7 of these pi's over 2. Notice pi over 2 times 7 is 3.5. That's down here. That's negative 1 times 5 is negative 5. So if this is the point 5 comma pi over 2, then negative 5 will be down here. Remember, we have to reflect it. If you take a negative r, that reflects it right over the pole. So what am I concerned with? Where is the head? Now, 51 degrees means I'm going to have something here and here. Another 51 degrees puts me at 102 about, and then I have 2 more here snuck in. If I'm going to the spine of this here, I'm finding that this is about 51 degrees between each of these here, 51 degrees, another 51 degrees. So we can see that the head is down, and we only have this theta equals pi over 2 symmetry. The only thing here I'm changing is a negative, and without doing all the work, you guessed it, the head was down. Now it's going to be up because I just changed that sign, and 51 degrees means 1 2 there, and then 1 2 here, and 1 2 here. It's just math. And here we have theta equals pi over 2 symmetry. So the left side is matched with the right side.